So I decided to make a video on some basic definitions that you need to know when we're talking about graphs. So we moved into chapter 6, and in chapter 6 they skip over some basic concepts of graphs because in chapter 5 they covered it, but we're not covering chapter 5. So I just want to go over some basic definitions dealing with graphs. First of all, the graphs that are being talked about in chapter 6 aren't like the graphs that you've probably seen in other math classes that have the x and y axis. That's not what graph means in this context. I'm going to draw a graph, the type of graph that is being talked about in this chapter. This graph here is a connected graph. First of all, let me go over these two. These are the two most basic definitions that you need to know: vertex and edge. Vertex is a dot. So these dots here are the vertices. Each one's a vertex. So in a graph, the vertex is the dot. It's usually labeled with a letter. So this is a vertex, that's a vertex, that's a vertex. Edge is a line. So this right here is an edge, and that right there is an edge. Very, very simple definitions. Vertex is a dot, an edge is a line. And all together, this is a graph, okay? This particular graph is also a connected graph, meaning every vertex that's in this graph can be traveled to or is connected by an edge to the other ones, okay? So I can get from C to B. I just have to go from C to A first, and then from A to B. So connected graph, you can look in the book for the exact definition, but it basically just means that every vertex, it's possible to get from one vertex to every other vertex in the graph by traveling along an edge. Let me draw an example of a disconnected graph. So we could have like the same type of graph, but maybe there's also another vertex out here that doesn't have an edge going to it. This graph right here is disconnected. There's no way to get from C to D. There's no edge that connects them. There's no way to get from any vertex actually to D because there's no edge going to D. So this is an example of a disconnected graph. This is an example of a connected graph. Now when we get into the actual subject matter of chapter 6, which is traveling salesperson problems, you don't really have to worry about what a disconnected graph is anyway, because all our traveling salesperson problems deal with connected graphs. So, but those are the basic definitions. Connected graph, every vertex, you can get from one vertex to any other vertex in the graph by traveling along an edge. Disconnected graph, you can't do that. Vertex is just the dot in the graph, and an edge is just the line in the graph. So those are the basic definitions that you need to know. For any other definitions you need to know, the textbook's a good source, but two of the other main definitions you're going to need to know are path and circuit. Now, there's different types of paths and circuits. In chapter 5, which we are not covering, they talk about Euler paths and circuits. So we're not covering that, so you don't need to know what that is. In this chapter, you do have to know what it means to be a Hamilton path and a Hamilton circuit. So that's what my next video is going to be on, Hamilton paths and Hamilton circuits. And also in the next video I'll talk about complete graphs and traveling salesperson problems.